Okay, so today we're going to talk about how we solve things by factoring. And you've done a lot of examples like this in the past, but we're going to just go through a couple. So let's say that I have x squared plus 6x plus 8 equals 0. And so if we were going to solve this by factoring, we want to think of two things, or two binomials, that will multiply together to give us this trinomial. Those two numbers that multiply and add here should be 4 and 2. So we would find that this is x plus 4, and this is x plus 2. And again, you're not quite done here, because these two things will multiply together to give us 0, which means one of these things has to be 0. So the x that would make one of these things equal to 0 would be x equals negative 4 for this one, and this one would be x equals negative 2. And those would be my two answers. So those are the easier kind of problems. Let's look at some of the harder ones. Okay, for the second example, this one is a little bit trickier because there is a term out in front that we can't divide by all of these other numbers. So because there's an a term out in front that we can't divide by all the numbers, we're going to take our first number and multiply it by our last number, and that's going to give us 60. We're then going to take that 60 and think about what will multiply together to give me 60, but add together to give me 19. That should be 15 and 4. And then we're going to rewrite it. So we'll have 5n squared plus 15n plus 4n plus 12 equals 0. So again, we didn't do anything special. We just, instead of having a 3-term thing, we turned it into a 4-term thing by finding what our middle number added up to be. We then cut it in half, and then we factor the two parts. So the first part we factor, we can take out a 5 and an n, which will leave me with n plus 3. Whoops. We're going to factor this second part, which a 4 would factor out of the second part, leaving me an n plus 3. I could now see that this and this are the same, so we can factor that out and get n plus 3, and then factor the other part out and get 5n plus 4, and these both again equal 0. This one is really easy to see what would make that equal to 0. That would just be n equals negative 3. This one is a little bit harder to see, so because it's a little bit harder to see what makes that equal 0, we'll do 5n plus 4 equals 0. So we'll set it equal to 0 and solve for it. Subtract 4, get 5n equals negative 4, divide by 5, so n equals negative 4 over 5. And if you check that in a calculator, which we could do really easily, so let's just double check. If you do 5 times negative 4/5, which is negative 0.8 plus 4, you see that you get 0. Okay, so the simpler way to do this is kind of solve for what you want to know. You want 5n plus 4 to equal 0, so you just set it equal to 0 and then solve for it. Let's do another example. Okay, again, when I look across this, the first thing I want to do is see if anything divides. And I can't divide by 9, but I could divide by 3 to make it a little bit simpler. So when we divide this thing by 3, we'd get 3x squared plus 22x plus 7 equals 0. We then are going to take the first number and the last number and multiply them together, which will give us 21. And then we have to think about what multiplies together to give us 21 and adds together to give us 22. That's 21 and 1. And then we'll replace our middle term, giving us 3x squared plus 21x plus 1x plus 7 equals 0. We'll then go through and cut this thing in half, factor out the front side, giving us a 3x. That'll give us x plus 7. We'll factor out what we can factor out of here, which should only be a 1, because 1 and 7 are only divisible by 1. We'll again take the things that are the same, which is x plus 7, and we'll take the things left over, which is 3x plus 1. Set them equal to 0. This one again is easy to see, which is negative 7. This one again is harder to see, but it's x equals negative 1/3. Again, if you can't think of that off the top of your head, just set it equal to 0 and solve. And you can see again that your answer would be negative 1/3. Okay? So again, as you solve through these things, the biggest thing to realize for any of this stuff that we do is for factoring, all we're trying to do is break it into its two binomials and figure out what makes that equal to 0. Factoring is a lot faster than completing the square that we did the other day. So if you can figure out something that factors, I would use factoring. When I wouldn't use factoring might be when I have this number in front. As you can see, when you have a number in front, this kind of factoring does take longer than the other type. So completing the square may or may not be easier.